All right. Hello. Welcome to our March webinar. I am Nick Augustine. I've Grace Technologies IIoT Business Development Manager and Training Manager as well. Joined this month by Trace Hagee.
Yep, I'm Trace Hagee. I'm a field application engineer for our IoT GraceSense condition-based monitoring line. I work directly with the end users to install the equipment and then review it, make use out of the data afterwards.
This month, what we decided that we wanted to talk with everyone about, as Trace and I have been all over the country working with a lot of different maintenance teams, learning best practices and how different teams are becoming successful with our equipment. We've learned a lot of things about how every individual company is interpreting that data and how they're going from the numbers and that data to insights and action. So we wanted to share that with you. We have some case studies and some customer applications that Trace has worked with personally, so that he's going to walk us through how that conversation when we saw that data happened, how the customer interpreted it, and what decisions and actions were made off of that. So should be a very fun time. We will have a Q&A at the end. So if you have questions that come up along the way, we'll make sure to address them. So just throw them in the chat. But during this webinar, we're going to talk about a few things. One is how to take that data, go into actionable decisions. Another one is how to avoid alarm fatigue, because making sure that customers are successful with predictive maintenance, with gathering data and acting on it, one of it is to make sure that it is useful and reliable. And we've had a lot of teams come in and say that they get nuisance alarms and you cry wolf one too many times and it just doesn't provide value. Is that you find that pretty often?
Yeah, that's a very common piece we see. We see whenever we install this system, we're normally coming in and there's another system that's been tried out before. So we've had a very unique position to be able to see previous faults of other systems, of our systems, to be able to learn from that and really get use and actionable data to the customer very quickly.
Yeah, some of the stuff we'll talk about is reporting and making sure that you can take the data and get something else out of it. Show it to others, make sure that it is useful outside of just the diagnostic time frame. And then the last one we're going to do is show how using that data gets us from reactive to proactive planning. So get us in front of these failures, have a window of time, a window of recognition or notice that you can extend, and how to reiterate that and drive it further and further and increase that notification time. So moving forward, our first slide that we have available, we're going to talk about or I guess what condition monitoring is, what you should expect to get out of the system before we go look at the data, right? All right. So when you have first introductory discussions, are generally the customers aligned with each other on what they expect to get out of a condition monitoring platform?
No, that is normally our first talking point, is finding out what use they'd like to get out of the system, how they were kind of onboarded onto their past system, if there was one present, so that we're able to really tailor each of these onboarding programs that we do to the specific customer. Yeah, to be able to get that quick actionable data again.
Yeah, I think we've talked through the almost triple digits of pilots we've done in the past year. Not two of them are really handling data the same, or they're getting use out of it, but each one of them kind of applies it to their own operations and their own style. So where you need that data to go, who's making decisions and where they're looking for data, other process data that you can get in front of it to help correlate it, those kind of things. But as far as like the defect classification and helping guide people that aren't experts, are you seeing a lot of that offered out on the market? Things that if you're not an expert, how to still get use out of the data?
Mhm. Yeah, we do see just some more black box solutions for this. So we've seen, you get a 1 to 2 sentence summary telling your maintenance floor personnel to go look at this specific defect or this part of the machine. What we've seen though is it's really a black box solution where you don't get much more information past those couple sentences, which does not really instill the confidence you want from your maintenance floor personnel. So the instant that that floor person gets told to go out to machine, gets a false alarm. Uh, they can't dive into the system more to understand why it was pushed towards that specific decision. So the confidence is lost in the system very early. So I think we have a great solution that kind of bridges that gap, allows us to give more confidence to the user, tell us why we're seeing a specific fault, give a confidence level to it, and just give the more of a power user feel to the end user.
Yeah, we didn't start that way though. We definitely that we came to that product after 5 or 6 years of reiteration and work on to making sure it was useful, making sure we were helping customers interpret the data and understanding what they should expect to see. Because in my experience, the biggest question is what should I expect to see? I don't know if what you're showing me is what I should expect to see, or if I should expect it to change, or I guess the mentality that a lot of our customers had in the beginning was just to set sensors on a motor and wait for it to fail, like wait for something to happen so they could learn through real life what that signature looked like. So we've um we've kind of worked a lot more efficiently on onboarding that instead of having to wait for a failure to see that. But we do have a conveyor case study from a couple years back when somebody did that we can talk through and how that data, one, if you do have a failure, what you can see, how you can interpret it and diagnose it. But two, if you are monitoring it, how you can see that and have advanced notice and get in front of it. So if we want to switch to that slide, we'll show you some data here. And then what you want to give us a little background on this customer trace, just kind
Yeah.
of high level what they're doing?
Yeah, so as Nick talked about, we've learned from our past deployments too. So this was initially on our legacy generation sensor, where we didn't have the as rigorous onboarding process, baselining, thresholding, kind of just given to the customer, and they make use of the tool how they see fit. So what they saw uh, was they put these sensors on, kind of let them run for a couple of years, didn't actually apply any thresholds to them, any alarming. And they came back to us after a couple of years saying, hey, we think your guys' sensor missed a defect from us. We looked at that sensor and then they got back to us a couple of days later saying, actually, we were looking at the wrong sensor. So we realized how important the onboarding process is to be able to make sure that they know where the tools are, how to make use of the sensors and the data that they're returning as well. So specifically, this one did result in an actual failure. It was a bearing failure that happened on that February 25th date. So what we saw
Well,
was,
while we're looking at it, while it's up on screen too, and if you can leave that up, that'd be great. So like, just make it a little bigger so people can keep seeing it. What are the lines that we're looking at on this chart?
Mhm.
So, just to give people a baseline of where we're starting and how we see what the data coming in is. So it's vibration for one, is what we're looking at here.
Yeah. So this plot specifically is looking at the overall RMS amplitude for our three axes of vibration that we return. So normally your axes of vibration are split into your axial, which is with the shaft, and your radial direction, which is both vertical, perpendicular with the shaft, and then vertical coming out at you as well. So we return all three axes of overall vibration. That's what this is looking at here. This tells us more general information of a more check engine light. When you see it get past a certain threshold, you know there's some issue going on that's causing more vibration. Does not point you towards specific defects, but it gives you a good, um, pre-planned data to be able to look at for a scheduled downtime instead of
All right.
as it's
So,
going along.
like, you don't need to look at 1x, 2x, or bearing frequencies because it's all going to roll up into the overall for that direction anyway. So,
Exactly.
kind of start at a high level and see where you need to look further in.
Yeah, and we'll get more into the banded analysis as well. But this is really just proving out that this continuous monitoring, not doing every quarter, doing your normal pass-through runs, having this continuously on shows us the full condition over the multiple years that they had this equipment on. So with this overall vibration analysis, we then looked into that top axis of vibration there, the top axis that was the vertical. So on that individual banded analysis, we look at mostly the 1x turning speed. So that goes off of whether it's a fixed speed motor, a motor on a VFD. It looks at the shaft speed directly at the sample, and it bases most of your vibration energy will come at that 1x interval with the shaft turning. And we'll break that into 1x, 2x, subsynchronous as well for all non-harmonics. But generally, we use all of this data to be able to push towards a more specific defect. Um,
So when I look at this as like if an untrained eye, it looks fairly smooth and consistent in the beginning, and then it gets like kind of choppy here, smooths back out, choppy. What are you seeing at this? Like, what's calling attention to when you look at that?
Mhm. So we have our general baseline that we would have set up at around that February 10th, 11th level. So we would have gotten an initial fault on the run the week before that. But along with that, we see just a heavy increase in vibration around that February 18th range that would have thrown up a alarm right away. So that really tells us that we have to look at the full running of the equipment and not just during specific times, which is why that baselining period of a couple months, it's really important to see the machine in different states, not just one state of it being loaded. So
Yeah,
that's very important as well.
have some context with it and understand the variables it goes through. Do we want to look at more data to show something more signature than that, or
Yeah.
is there other channels that we can see that will give us a little more detail into the alarms?
Yeah, so off of this, we looked at the most elevated axis, which was the vertical, and we got more into the band analysis. So looking specifically at the 1x RPM band, the 2x, this pointed us towards a cocked bearing. So different vibration signatures will point us towards different defects. So this specifically we looked at manually, and we saw that if we had our system set up properly, we'd be able to catch this fault, and the defect would have been classified at least 2 weeks before. So if we can look into that slide that
Yeah,
is showing
because
this
this one
here.
shows, yeah, a lot bigger separation between the bands, it looks like. So a lot more exaggerated changes.
Mhm.
So is that helping you set accurate alarms or find the root cause of what's actually causing that vibration?
Exactly. Yeah, that's where we get back into the root cause analysis. So we're able to get that, hey, you should look at your system from the setting the alarm on the overall RMS amplitude, and then we're able to look at the specific bands to be able to tell a pointing towards more of one defect. So this specifically was a cocked bearing, but it enables more specific repair planning compared to just a general check engine light that we were talking about.
Yeah. So one of the things when we talk about there, is how does our system help guide towards what that shows? Because if you don't know what all those different bands elevated are saying, how is that useful? They would say we're not vibration 3, 4 level certified. Um, and the other concern is where that data goes because we don't want to give anyone a whole nother platform to open up and look at. We want to have that data land where you're already looking for process information for your maintenance information, whether that's historian or OSI Pi, factory talk, where it be. Um, we want to talk through how we kind of help people start diagnosing that themselves or
hmm Yeah, we can get into that's a big gap that we knew we had to bridge from our first system was we have all this data. Now what do we do with it? How do we interpret it? Like you brought up, if you don't have a maintenance personnel specified to vibration analysis, how do you make use of this data? And again, get back to how do we get actions out of it?
yeah,
So,
because I know from our side of looking through this that we're gonna have called out that defect back way back in the beginning. We're gonna have identified the specific defect here on the 21st
mhm,
as that cock bearing.
mhm,
So if we can go to the next slide, we'll show if you don't have that capability on site, how you can subscribe to our software to help interpret that decision. But this one's going to show you our like a periodic table breakdown of how we're starting to see where those channels are presenting and what that could potentially cause. You want to give a little background on this and how you use it with
yeah,
customers?
yeah. So this is our periodic table of faults. We worked with a local vibration analyst company who has been collecting data over a couple decades to be able to put together and simplify vibration analysis to these faults that are presented on the periodic table here. So based off of this, we use those different vibration bands that we pointed out in the past slides to feed into this. At its most basic, it's a rules-based system that we apply machine learning to as well. But at its most basic, it's a rules-based system saying if you see 1x RPM in the vertical direction this way, accompanied by 2x vibration this way, it points you towards a certain defect. So we use this, and this is what I was talking about earlier. for not offering just a black box solution where we just tell them, here's this fault. As you can see from the left side, we have a defect list that has a confidence meter as well. So we like to give a most likely and unlikely to be able to show the specific indicators that are telling us that reason. We have on the next slide here, we get into, as you click into each of these defects, you're able to get these different indicators. So we have our positive, our counter, and our missing ones. So this is what allows us to start giving a confidence level to that maintenance floor person to say, here's a couple of defects that we think it could possibly be. You need to do some more analysis to uh, push towards a specific one, maybe on-site phase analysis, anything like that.
Yeah, every customer, it seems like if the computer tells them what a fault is going to be, their first goal is to prove it wrong. So, and like inherently, you're just like, nah, it can't be that. This machine doesn't know more than I do. So we took a lot of effort into this. We want to relay the failure and the likeliness of it as humanly as possible. So this is the same information you'd get if you were standing there doing the analysis on the motor. We're going to show you what is showing up, what is saying that this fault is present, but what is not there that should be. If it is a gear tooth or a misalignment or an unbalance, like these seven things we would expect to see, we're seeing five of them, we're missing these two. But then, including to those, we add anything that's showing up that shouldn't be. So if there's vibration elevated in the subsynchronous, but for the fault we're looking at and seeing most of the indicators that shouldn't be, then it's going to call that out and let you know that there's potentially a secondary issue, which could be changing that resolution.
Mhm.
So it is really a guiding step that aligned with other data. If you can overlay it with stages of your process or what's really happening in your facility, it can really increase that confidence or that ability to go out there understanding what the problem that you're walking up to really is.
Exactly. Yeah, we think it's a great tool just to be able to learn a little bit too. So, depending on how much you want to get into, we have people that through this onboarding process really want to get into more of the vibration analysis themselves. They kind of we set up the thresholds for them initially. We let them go, and based on this tool, they're able to point out it's broken out into the different harmonics. So you're able to really specify where your defect is based on the indications that we're providing for you.
Yeah, so once we had this ready, we put it to market and we started addressing customers with pilot programs so that we would be a lot more involved in the first 3 months of the deployment. We wouldn't have to have anyone set sensors out, wait for something to fail to figure out what it looked like. And when something did change, we had software that could kind of walk them through the first steps of what they might be seeing without having to make a phone call. And that really changed a lot of the reception of the product, because when 2 out of 5 times you can interpret data and make a decision, but you find yourself 3 out of 5 times having to call for support on the product and get interpretation or get assistance walking through it. It's it makes you very hesitant in rolling that out further. So getting to a level where maintenance teams were a lot more confident in that decision making, we realized with the 3 month onboarding and just every 2 or 3 weeks meeting and looking at the data as a team, by the end of the second month, the third, fourth meeting, people were making decisions. They were starting to confidently take actions and come back to us and say they're excited to see what the difference was, and start thresholding alarms and getting really involved. So we address that just by starting out small with a few sensors, understanding what that data is showing, making sure it goes where it needs to live and gets read and interfaced with the employees, gets integrated into their daily life. And then once that's successful, then we can expand. But at that point, they're on their own. They're not calling us back to help or reconfigure anything. They've kind of owned the process.
Exactly. Yep.
Yeah, it's very fun to see. I think we have another case study that we can pull up and we talk through what is this? A couple more conveyors that we were looking at
hmm
after that
Yeah.
methodology. So what are the couple areas that we're looking at in this slide?
So yeah, this was after the customer reached out to us on this previous sensor deployment. We decided to upgrade them to our new generation, kind of put them through the onboarding pilot process that Nick's been talking about. Through this, we were able to get a lot better thresholding, and also we were able to catch two specific faults that our defect classification pointed out as well. So the first one on the left side here was a specifically a mid shaft bend and a belt drive misalignment kind of combined together. So this was specifically looking at the 1x RPM and the 2x RPM. So this slight increase in this specific band, could tell us that it's more of a mid shaft bend compared to near the bearing as well. So we're really able to get with multiple sensors and sensing locations a more specific defect as well. But this was caught and then fixed during planned downtime, and the same case for the image on the right as well. A little bit different fault. We saw more of a mechanical looseness and also just a bearing looseness too, along with the crack in it.
So that brings up a very common question. One of the first things people ask is, how many sensors do I need on an asset? Um, what's your general answer? Because mine, talking through it, it kind of depends on how specific you want to know. If you want to dial into left or right side of the machine, we can do two. If you want to dial into a quarter of that, and we can get real specific. But where does it get overdone, or what's best practice, I guess, for how to decide that?
Yeah, yeah. So if you're looking at just wanting to put one sensor on the motor, that's more looking at your general check engine light overall vibration. We like to at least for our onboarding program, we give four sensors. So that allows us to at least get two on two different machines. You're on the motor and you're on whatever the driven component is, both on the drive side bearings to be able to look across that shaft as well. So that's really our baseline is having those two sensors on at least the motor and the driven component. And then we have users specifically for pumps and other pieces of equipment that want to look at the idle side bearings as well to see how their process is affecting those specific monitoring points and be able to compare it with the drive side bearing too. So if you want one on each bearing, you can do it on the outboard of the motor, outboard of the machine too, hit both the drive side and the idle side bearings. But we like to at least for showing value right away, get two on both drive ends.
All right, but one sensor will show you change over time, and it just make it a little more difficult to identify maybe the specific defect or.
Sure, yeah, you can't really specify, you can't isolate it to the direct motor or to the fan, which we'll have an example later showing how powerful having those two sensors across really is. We're able to kind of isolate it to the fan side instead of the motor, but we'll get to that as well. But yeah, that really allows you to start isolating faults instead of saying go out and look at the entire machine. It's look at this side, then look at this specific bearing, as in depth as you'd like to go.
All right, so what realistic change did this make to their process? Once we started having them more in front of the data, were they able to get those repairs scheduled in and addressed, or how did it change their operations?
Yeah, so that's a key part of the onboarding too that you bring up is figuring out what their maintenance and workflow is going to be. So when you have this alarm hit, how will your team react to it? So we have these going directly to the operator level now. We're able to catch these out a couple weeks in advance to where it doesn't have to be a go check on the machine the instant you get an alarm. They instead get that alarm, they review the data.
Oh, they know they have a bigger window, so they can. All right, even just to checking into it, they know
Mhm.
they have a window. That's
And
comfortable.
you can see from the plots here, you're able to very easily tell on these couple faults that there's increased vibration. It is very drastic, and then you can start getting into the individual bands if the operator would like. But if not, he's able to then tell his maintenance personnel to look at it. These are both fixed during their planned downtime. When the previous one was a fault that happened during and took their process line down. So that was just the instant difference we were able to make with kind of getting the new sensors in, doing the onboarding process, thresholding them properly. These were all caught by the user autonomously from us as well.
All right, all right. Is there anything else you want to pull up on this one, or do you want to move to the next slide? Because I think it's about grabbing the right bits of data and having that confidence.
Yep, yeah, we can move on to the next slide here. I believe yeah, just talking about the different plant floor push versus the corporate as well. But
Yeah. Oh, this is a very interesting one. And this is our pilot starting small was a big reason for learning this difference between corporate directives and plant floor reality. But there seems to be a very big push, rightfully so, to get aligned with condition monitoring. Big corporations, many corporations, everyone seems to be aligned with thinking that this is the path forward. This is how you get more insight and improve your operations. Um, it doesn't seem to be figured out the best practices or the way to do that or the most effective way. But the reason being is everyone is set up a little bit differently. Everyone has a different way that they're operating, responding, and there is not really a one size fits all solution that will be effective. We have found ours, we made it very versatile on how we can distribute data, whether we go to the cloud, whether we go into a PLC. And that alone has given us some flexibility to go more nationwide and hit corporate type deployments where different facilities have different requirements or capabilities. But what seems to be happening is that instead of it being onboarded and brought on into your team and used, it's this box that's being checked when you order new equipment that it comes with sensors. And then your crane comes with sporadic sensors, your ball mill comes with random other sensors, and they're not always labeled correctly or uniformly. We found them not to be scaled correctly out in the field when we encounter them. But what we find more is that nobody's using them or nobody's getting a lot of valuable data out of it because it's just so much streaming in and it's not organized or actionable when they receive it. And simply by restarting that process with four sensors and allowing teams to get it under their belt and figure out how to use it and become proficient with it, and then expanding, that's been a lot more. We've gained that engagement from the plant floor. We've found a condition monitoring that allows the plant floor to interpret data and act. And as a result of that, since we're starting a lot of these with just four sensors, we're encountering a lot of side by side comparisons and corporate pushbacks on expanding GraceSense because there's immediate action versus whatever disparate systems that they've started encountering. So have you kind of seen that, or what's your thoughts on how companies are approaching the corporate mandate for condition monitoring?
Yeah, it's exactly as you're saying. It's a big corporate push that we need sensors. We need condition-based monitoring. It's not applied properly to the correct project manager. There's no connection between that project manager and the company that's doing the condition-based monitoring. It's a really separate process to where if you don't have that buy-in at the plant floor, you're fully relying on another company that probably the data you don't own, it's all owned by them as well. You're renting equipment. You're kind of at their mercy for being able to make use out of it. That's one case. The other case is the OEM sensors that you're talking about.
Hmm.
These we almost see never get used properly. They're put on the machine to start. You're told kind of how to set up at the beginning. 2 years later, no one knows that there's even sensors on these machines.
Yeah.
So it's a very important process for us to really make sure that we're not just getting data in to get data in. We start small with a couple sensors. We prove out value. Our pilot kit is very non-intrusive. We have magnet sensors. We have an LTE gateway. Everything's very quick. Within 10 minutes, we can get it set up on a couple motors, start showing data immediately, start relating that data to what we're seeing, instead of
Yeah.
it just being, let's get data in, let's get these sensors on.
So I remember you being at a pump house, I believe, for a water company and installing sensors, and there were already sensors in the building on the asset that you were installing them on, and you decide to just because our data comes on pretty quick, so you just check it against a sensor that's already there, and that wasn't an easy process. The sensor that was already there, it was both labeled incorrectly, scaled improperly, said it was vibrating what like 8 inches a second or something.
Yeah, yeah, we were seeing the pump about to fly out and hurt us from their sensors. So it was a big push just right away to even relate. The thing is, this is good data if it's scaled properly, if it's applied to the correct, if you know what to do with it.
Yeah.
So we can even use, we had 2 years of that OEM sensors data already proven to us. So we're able to tell them these two sensors are actually switched for which pumps they're on.
Hmm.
This one's scaled incorrectly. And then you could start relating all of that past data too. So that's another just a key part is we've made use out of previous customers' data or previous companies' data on this end user, and then relate it to ours, be able to scale that delta for what vibration we're seeing, really give them confidence and give them history of the past data and the defects that they've seen. That gives us a really good point to be able to baseline ours and fine tune our system too. So it's a general help of being able to relate the data to their past defects that they've seen, be able to make use out of it, and be able to use it to strengthen our system and the onboarding process for the user.
All right, cool. I think the next case study we have is it a wet collector fan? Is that what um is one of what kind of applications? Because I love the data that you have from this one. It's very visible changes in state. But what kind of applications, what kind of customers are going to have this kind of equipment for
Mhm.
this?
Yeah, so this first one we're looking at is actually
Oh, it's a
a
trim
trim
cutter.
cutter,
All right.
yes. So this was over time. We're on some material handling equipment, some fans, some trim cutters. This specifically was looking at a very specific use case for a trim cutter blade doling over time. So you could see in the black uh, bar there, that's the axial direction. This is just showing the overall vibration of all three. It is very clear over time which direction is the
That's
main one that is shown from the process of actually dulling that blade. So the overall already tells us a really good story of being able to set that threshold, get to a point of where you don't want to replace the blade even at the start of when it's dulling. You can get some more use out of it, but when that dulling blade starts putting more pressure on your bearings, starts making it work harder, that's where it can lead into other faults.
mm-hmm.
So we really saw as this blade dulled, specifically we saw the subsynchronous, which is non-harmonic energy. This is vibration that's happening not every time the shaft spins at a certain harmonic once, twice. That's the trim cutter blades are actually separate from the rest of the shaft. So we
Okay.
see that in the subsynchronous, and then as that subsynchronous rises, we see the bearing energy shoot up as well because that's putting a lot more stress on the bearings. So this specifically, the idea, alert over overall thresholds, but then use the bandit analysis to really dive into more specific defects and fine tune it there.
Yeah, and then you can take that and kind of align it with because eventually, if you let that start vibrating too much, it's going to start affecting other parts.
Mhm.
But you can find that sweet spot of when those blades need change, so you're not wasting resources and create those windows, and then you know exactly how long that takes over time. So it just increases the efficiency of all those actions and gives you some data to validate it. Alarms that can be set and just automate that stuff that you're otherwise doing.
Yeah,
So.
exactly. You're able to plan out when exactly you want to replace the blade too. So whether that's dependent on I don't want to replace it too early because it still has some use out of it, wasting some money there. I really just want to replace this at our planned downtime. So it doesn't matter where in the spectrum it is for how dull it is. We just want to make sure that every time we're up and running again, we have no chance of that blade becoming so dull that you get material buildup and then you see just the shoot up in vibration that's not it's more of a spike instead of this gradual flow of it doling.
Yeah, and I think if we go to the next slide, we can talk about because you can catch this in spot checks. If you're doing like your monthly routine, depending on how long that window of notification is on the failure of the specific asset. The reason for having permanent sensors on there is for when you respond to one of these failures, when you go do a maintenance intervention, an alarm goes off. Ideally, what we want is after that is someone to go back and look at that data and look at the couple weeks before you see that vibration go crazy, see if there might be a leading indicator. If there's something that can tell us that that vibration might start going crazy, if we can see a rise in one direction or another, then we can go in and address that and start getting increasing our window of notification. And that's what gives you like that conveyor belt assurance where you know you have time to even go look at it and vet it because you have a few weeks instead of just a few days notice. So that's what we want is that yes, your alarms go off and you still react to that. You've increased the how early you're reacting, but the way you refine and improve the system is by continuous improvement and reiteration. So when you react, pull up that data, see if you can push that window even earlier in that process until you're comfortable, until you don't need to. But when you own that process and you own the ability to do that and you can change it and alter it to your facility, you become less reliant on third-party resources, on calling for that interpretation, the help. And what we've seen is when you engage with a tool that requires you to stop what you're doing, call for support, and get help, teams start using it begrudgingly. It doesn't flow into their process. It's not at will that they can do it, and they're stuck having to use a support network that they don't want to have to use. So being able to own that process and adjust it yourself and have your team be capable instead of relying on a third party company is huge. And that's one of the reasons why the plant floors are finding it so usable is because they're not on support calls.
Yeah.
All right, we can move to the next one. We got a few more really cool data points to show. Um, I think this one might be the wet collector fan, or I'm just gonna keep hyping that up until it finally shows up. Yeah, and again, we do have Q&A if there's any questions that you guys have as we go through. Um, but we'll give a few examples. But Trace, you want to talk through this? It's a wet collector fan. So what kind of customer is this and what is a wet collector fan?
So this specifically, a wet collector fan is to be able to use water particles to drag down the bad air, use the fan to really purify this air from their process.
Huh.
So this was um, a slide that was added to talk more about the multiple sensors on the machine. So we have one on the actual motor of the wet collector fan and on the after the belt drive on the drive side bearing of the fan as well. So from this was, I believe, our second or third data review. I believe our second. But we were able to point out that we saw a general increase in vibration over time, and this was followed by a immediate drop. So from this, we're able to look at the overall vibration, see that there was an action that was taken on the motor, most likely. And since we have that direct communication with the customer, we're able to confirm with them that this was the certain defect, the buildup that we thought, and not just a change in process, a change in loads, a change in run speed. So through this, we looked at the overall vibration of the inboard motor sensor and the actual inboard sensor on the pump too.
Mhm.
We saw that the pump sensor vibration was actually shooting up first. So we could decide that the vibration was actually happening downstream of the motor and causing vibration back upstream to the motor.
All right.
So we can point out there is an imbalance on the entire system. We could see from just the one sensor, but having the extra one on the pump allowed us to see that the fan imbalance, that the imbalance was actually on the fan. So then we hopped into that individual, that second plot that was below that individual band analysis. We could see that the 1x RPM was shooting up on both of them. And with
Is that the
this,
red line?
yep.
Right.
And with this in conjunction, it would also the bearing energy, that kind of teal one, would go up with it. So these wet collector fans, since we have knowledge of the specific asset, since we have direct communication with the customer, we're able to call out to them and predict before we even talk with them that this was a material buildup. These machines are notorious for it because of the wet collector nature. So it builds up on the fan blade, causes extra stress on the bearing too. So you see your one extra bearing, and we can point to this being an imbalance on the fan side for material buildup instead of the motor. So because of this, they did clean out the machine and saw instant vibration improvement, it decreasing and then putting less stress on the bearing.
So
So that, yeah, go ahead.
you've mentioned something a couple times that I just want to call out. That you and I guess I did say in the beginning that you've been on site, you've seen all these assets, you've touched them. You've when we do the pilot, you go out and you assist with the deployment, whether it's you putting the magnets down or them. That seems to be making a big difference. We have in some of the side by sides that we've done, um, different manufacturers are using third parties to go in and install or monitor this equipment. And it's people trying to interpret vibration on assets they've never seen from a process that they'd never went and understood and watched. And the interesting part is as we go to conventions and different trainings, the vibration world isn't that big. They're the same players, and sometimes they bounce around. But you hear feedback that it is difficult to determine vibration, determine how confident you can be in alarm on something that you've never seen or you don't know if someone's out there, if something upstream is affecting it or anything like you said. So, um, the reliance on a third party seems to be a risk factor in the deployments of this, and it affects the confidence of the teams using it. So it is it's interesting, but we do send direct from the manufacturer our engineers out to support customers and have you very hands on from the all aspects of it, from future product design into how customers are deploying and using it.
Yeah, yeah, no, like that, to be honest, that really helps out me as well to be able to decide, we see these certain pieces of equipment. We want to be able to, I can see we have a whole line of wet collector fans. So I know once we get on one, we determine what the material buildup is. We can extend that process to the other assets. Along with that, while I'm on site, I'm able to see just facility vibration as well. There's a lot of signals that can give you erroneous defect classification in terms of just general plant floor vibration, how the mounting is propagated throughout multiple pieces of equipment. Like we had one fan frame that was over it, um, was the mounting for 4 or 5 different fans, and we were seeing basically when this fan was off, a certain vibration would shoot up. So we were actually getting erroneous signals from um, a different fan on the same frame, which I just seeing that from plots would have been impossible to tell. So being out there, being able to see the physical equipment, instead of just having a picture of the one asset, you get to see the whole process. It really helps me fine tune not only that, but I get to talk with their maintenance floor guys to determine how they're going to act off of the data while I'm on site there too.
Yeah,
It's very powerful.
that is cool. We had another situation like that too. I didn't include the slide. We can go to the next one too because I've got a couple more, two more cases that we want to show. But one of them that I didn't include was a ball mill and a gold mine that there was a cooling fan that had some residual vibration going through some assets. So depending on how many sensors you had, you could really tell where it was originating from. But we didn't. It was very early in the pilot, and we were under, or the customer was under the assumption that there was residual vibration showing up on their ball mill, that their ball mill wasn't actually in fault. And when they had a motor service company come out to service that cooling fan, they're like, will you just check the ball mill? Like it does, the alarms are going off on the sensors, and they found a misalignment that they did not know they had. As standing there looking at the asset, so the ability to learn stuff about your equipment. Oh, this is still that, yeah, wet collector fan, so we can finish that one. But you do get to learn. We've seen maintenance teams acclimate to understanding their equipment a lot faster. That same kind of feel you can get after 20, 25 years of working with something, you can accelerate into a couple months of being able to see those data points and make that decision and correlate patterns.
Exactly. Yeah, being able to correlate it with multiple sensing options as well. So the vibration is not the tell-all for condition-based monitoring. It's a very powerful tool, but our sensors also inherently return surface temperature as well. So this is just a quick temperature plot showing that same wet collector fan. We can see an increase from that putting more load on the bearing that directly relates to increased temperature. But
Hmm.
our system can pull in any 4 to 20 milliamp sensor, 0 to 10 volt. Our common ones are CTs to bring in current on the motor as well, relate that to vibration. Being able to overlay these multiple sensing options, work with the customer to be able to look at their flow rates, be able to look at their fill times on certain agitator tanks we're looking at.
Hmm.
That's very useful as well to get the full picture. So on the next slide as well, we talk about making sure that you're tracking the correct signals here,
Yeah.
not just
Yeah, not just the things that, so ideally the easiest way to pick out what you need to look at, and usually on site, someone understands if they stood there and watched an asset, they could tell you when it was going to fail and why. We want to know that. We want to know when you're standing there, is it because this area starts shaking or current starts getting drawn more from over here, or does this get displaced? So, and we can just put a sensor there. All we want to do is automate your knowledge of knowing that happened. It's not anything more difficult than that. So, and usually people can tell you that I've operated this equipment. If I was the one standing there, I'd be in front of it, but we're not. We're out running around doing tasks everywhere else. So we just want to gather that data that you inherently know is showing you something and put it in a place where you're going to look to see that data. And by just breaking it down to that level has really achieved a lot of success and not overcomplicated it. We don't walk in going, all right, we're going to put down 250 sensors. There's going to be three on everything, and then we're going to tell you how to figure it all out and correlate it. We start small, we let them do it, and then they understand where their time is most spent. Where are you getting the most surprises? Where are you interrupting your schedule? And then they roll out to that area. And then they unlock a couple extra hours in their week. And then they roll out to another area and just It naturally expands, but there's buy-in and there's actual use and benefit of it. And
Mhm.
instead, we see a lot of people with a foot in the door and they're just really hesitant. So we don't want to limit to just vibration. We don't want to limit to just current, or we can do strain, we can do pressure, but we want to know what what indicates your asset failing. If it's in a data center and it's ozone, then we can get an ozone detector. But if it like hiss detection and pneumatics, we can incorporate other data points to make you more confident. So we manufacture the triaxial accelerometer. We get temperature, surface temperature out of that as well. But anything else that you want to bring in, we can. We don't have to manufacture the sensor. We can use a third-party sensor, let you build the best suite for your asset, and just bring that all holistically into one place. That sound accurate there? Anything else that the mean time between failures? So we do with the next slide too, we'll go up into that one. But when you have that early insight and being able to increase that window of notification, that's really making the biggest impact on your mean time between failures. So being able to reiterate that process and own it is a bigger change for your reliability team than just having an alarm. Especially if you outsource the alarm and someone else is monitoring it, all you've really done is change your reaction. You're still reacting. You might have got a one-time improvement, but you're still now you're getting a phone call and reacting instead of a PM that says that this is deteriorating.
Mhm.
So it's interesting to see the uh, what you have to give up if you don't have the ability to own and improve or change the process internally.
Mhm.
The if we go one more, I believe there's a corrugator on this one. That's what I'm hoping shows up.
Mhm.
All right, good deal. So this data review it's a corrugator that's picking up glue and pushing it with a big roller up against another piece of paper and pushing them together. The guy we were talking with about this, I don't think he wasn't technically trained in vibration, right? He wasn't like a vibration analyst that we were doing.
Not specifically, no.
All right. So, but one thing, just looking at it, when he just looked at the data when we zoomed out to 3 weeks, that's zero point 0.8 inches per second on that high peaks, zero point 0.9 in some of the areas, which is alarming. But the first thing he said is, that's a product. That looks just like our run cycle, our run schedule. And he's like, he couldn't remember offhand what it would be, but he's like, if I go grab a run schedule, that is going to line up with a specific product that is going through that machine. And he was right. But right at right up front, you can tell that. You can tell that something is a lot more rough on that asset, and you can see when, and you can start to address that, even if you know nothing else about vibration. You can tell that that's not constant and that something's affecting that. So, what kind of conversations did you have following this? Because from my understanding now, the team that's looking at this can tell the oil level off their machines because they've watched it so much.
Yeah, I believe also we were able to, like you're talking about, relate that to direct run schedules where they thought the most vibration would have been their thickest paper, but actually they checked the schedule as actually the thinnest paper, which allowed for more space and more vibration. So being able to run at different speeds depending on um, what cardboard you're loading in was very important for them to be able to reduce the vibration, which you saw with talking with the OEM as well.
Yeah, yeah, we that was the interesting part because we have a bigger perspective than a lot of individual facilities. So knowing that's a corrugator, knowing who made that corrugator, I was interested to see what their input was on why it was spiking in such hazardous areas of vibration. And as soon as we showed that vibration signature, the guy jumped up and he goes, I know exactly what they're doing and I can fix it. And it was just it's a harmonic wobble because the bearings are so far apart on that roller that it allows it to get in this state at a certain RPM that just starts vibrating it until it rattles itself to death. But he knew that if it operates like that in 4 months, he could tell me the first three things that would break on it, and that his service people would be out there very soon.
Yeah.
We've had a couple OEMs come up to us with that same exact thing as, hey, I have equipment, I go out and sell it, it should last reasonably a decade, and it is failing in 6 months. And I know what the customers are doing, but I'm not there when they do it to stop it or prove it or explain it. So they come to us and they get sensors, they kit it up, and they can start getting this insight. So the idea here is that we can start changing that. We can all you need to do to avoid that giant spike in vibration is jog the speed up or down a little bit,
Yeah.
and it goes right back into a very smooth operation. So the OEM is now building that into a feedback loop so that that can
Yeah.
auto adjust and correct itself instead of tear itself apart in 4 months.
Exactly. And this is the last thing we'll kind of talk about before getting into the Q&A as well. But exactly what you're saying, that's a kind of unique application where we're based on vibration levels directly changing the run speed. So the way
Hmm.
we're doing that is we have a direct PLC integration with Allen Bradley. We're a Rockwell partner. So we have an add-on profile that's really easy it's a dynamic memory map of the gateway and however many sensors are connected to it for our IoT system. And it allows you to be able to pull this data directly as tags into your PLC with just a couple clicks. So based off of this, we're doing a feedback loop to the PLC, building out some HMI screens with the end user. That's kind of a unique way that, during the pilot program, we like to really talk about where you want the data to be ported to, where you
Hmm.
want it to be integrated. So we have all of the cloud visualization tools that we showed you today to be able to help. We'll also work with customers to be able to show them what we're able to give them on the cloud side versus what they would have to do on the control side to kind of show the differing value. So along with that, we do just have a public API that you could pull out of our cloud. So there's a bunch of different integration options that we give to the customer based on, if
Yeah.
they want to look at overall, if they want to look at bandit analysis, how in depth they want to get.
From the company that brings you 25,000 versions of an outlet, will we'll bring you 25,000 ways to iterate this. But there is no one size fits all. If you deploy this, you're going to have a conversation with myself and Trace or one of our field engineers, and we are going to build this to your facility, to your assets, to what programs you're using to look at data, whether that's Factory Talk, OSI Pi, Maintain X, whatever it
Hmm.
be, Ignition. Whatever help we need to provide in that, if it's integration into a PLC, if it's usefulness of the online subscription. But yeah, there's many ways to approach this, and still looking for two people to do it the same way.
Hmm.
So,
Yeah.
did we get
Yeah.
any questions that come in, Sierra?
Yeah, to close this out, we can just go on to the last slide as well. We can skip past the rest. Kind of just shows us, getting to that proactive planning we were talking about at the start, being organized through that too. So this is through our platform, being able to plan maintenance based on just easy visualization tools, based on that initial onboarding process that we have. This is how we do it on our cloud, but we work with customers to bring it into their own system to make any sort of screens that they want to see. We basically inform them on what data we think will be valuable, what they want to make decisions off of, and then let them go from there.
All right, so this is if you don't have that team building up a big SCADA, big factory talk screen, they can use our version, use our engineering resources to visualize alarm and get all that functionality out of it.
Exactly.
All right, you want to read off some of our questions here?
Yeah, so our first question is, do you correlate vibration and temp for validation as they are relational?
Yes, yeah. So I'm guessing that one came in early, so we got into that for the later asset there. But yeah, those directly, especially on that bearing specific fault that we saw, it's very clear. So it returns surface temperature on our vibration temperature sensors, but that's just one of the signals we like to use while confirming out what we're seeing on the vibration.
Yeah, even for the same application in two different facilities, for cranes specifically is what I'm thinking of. We have some deployments focusing more on bearing temperature and some deployments focusing more on vibration. So, but we very often we correlate those. We try to put current over it as well. We try to find the things that are um, confirming because vibration can show up from a lot of places. There's one customer that has a tank application, and I think it's unbalanced alarm that'll show up from vibration, which could indicate three different things. But if it's unbalanced in current draw, they knew it was the impeller and the agitator in the tank. If it was unbalanced in temperature, it was the lining of the motor, and I forget what the third one was, but they could tell if it was a gearbox. But yeah, we want to use as many different channels as needed to isolate what specific defect it might be
Yeah.
or to confirm it. There's also the alarm fatigue. We did the multi-exceedance because there's some inrush or some startup vibration in a lot of processes. And more importantly, what that what we want to track is if you go into a vibration hazardous state and you stay there, that's bad. But if it goes in there during like the startup process or a steam injection process and comes back down to normal, then we don't need an alarm to say, hey, this happened because of the steam injection part. So we can build it so it requires multiple exceedances and lengthen the time before it draws your attention into it. So there's a few things we've done to kind of boost confidence and improve that fatigue feeling and make it more real when you get an alert.
Yeah. Yeah, and that's the example we skipped past too, was just
Oh yeah.
showing what was showing the pump that we were on, and being able to, it's off the start of every single cycle, it has very high startup vibration before its flow stabilizes. So really making sure that the alarm is looking at it during its normal operating state and not catching any nuisance alarms there too. So
Hmm.
yeah.
Next question is, do you have any good solutions for arc flash and temperature monitoring of bus bars, etc.?
We do. The other side of GraceSense that's not mine and Trace's IIoT is a hotspot monitor. So we do have continuous thermal monitoring. A couple options of it. One industry best practice is phosphor thermometry, which we use more in the medium voltage world,
And those
or
bus
we
bars.
or we have a thermistor based solution that's more individual buckets, 480, 600 volt level solution. Yeah, but definitely follow up with local sales rep. We can get more information on that. That's a very good industry leading product offering we have for that.
Yeah. Yeah, P70B. Yep.
Are there sensors for non-industrial applications for something like gear?
Something like a gearbox or a gear, just gear in general.
Gear in general is not what I'm guessing.
So we do, I mean, at its most basic, so you don't get that individual banded alarms if you're not on a rotating piece of equipment, but we do just return out overall vibration. One specifically lately was on a CNC machine.
Mhm.
We're looking at these vibratory bowls that kind of organize different parts into different places. So you can really, you could put it on a wall and get overall vibration. That's why I've
We
used,
have people doing that actually. We
yeah,
have an engineering firm that does structural vibration resolution, and they'll go get a baseline with our sensors just around facility.
yeah.
They'll implement a change and they'll get another baseline to show the change that they made in the overall facility vibration, which does start affecting assets and stuff. We've seen like in General Dynamics, or I gotta stop naming customers, but certain places that have a lot more background vibration, it does seep into different assets in different ways.
Yeah, yeah, and that's why it's definitely not it's definitely not meant to be a structural vibration tool. But like that fan example I was bringing up earlier, like I used it to be able to put it on the fan frame and see the vibration that's on the fan frame, um, in relation to each of the sensors that was on the fans as well. So it can be used as a tool, no matter what on the overall vibration. But yeah,
Yeah. Yeah, because one of the things I learned doing this, talking with customers, is just as often as identifying what the problem is, identifying what the problem isn't can be just as valuable. And that's what a few extra sensors can do that. It can show you what's residual throughout the area or what's coming from something else. So if you can confirm, I think it was we had a customer that had a tank start howling and put sensors on it just to figure out what might have changed to cause it to start making noise. And being able to identify that the gearbox is fine, but the motor's not, is useful. And if you don't know what the problem is, at least being able to see what's not under stress is useful. Have you seen that in a few cases?
yeah, that just gets back to more of our rotating equipment that we do, because we do gearbox, gear mesh analysis as well. But yeah, getting sensors on multiple spots allows you to isolate the defect. Gets back into
Yeah.
bring up the multiple sensors. Yeah.
We got two more. How does a contractor get certified on installing and interpreting the data for an end user?
So usually just with a few meetings with us, we have contractors that have taken on selling this and providing this to their customers. That was our big break into the quarry industry with this because they'd show up and they had a limited amount of time that they'd spend on site. So they wanted to know where the stress was, what building or what area they needed to spend their time in. So at a base level, we have some contractors doing just like red, yellow, green stoplight levels of where vibration and
Yeah.
where
Sounds good.
degradation is. Or but yeah, it doesn't take much. Generally, if there's any vibration training in that contractor, it's a couple hour long sessions with you just
Yeah,
navigating and what understanding our mentality and the intrinsic parts of it, but
yeah,
we've
no,
seemed capable of letting people run with it.
yeah, we really, and even using our pilot program with the system integrated with contractors is very useful as well. If you have some test equipment at your facility, having us basically run through what a couple data reviews, what a couple, like basically how we use the system to determine our analysis with your own equipment or a customer that is willing to do a little trial for you. Like we could, there's no better way of learning this than actually doing an application with it.
Hmm.
So we've worked to do a direct pilot program with contractors and with system integrators.
Yeah, I've been quite happy. It's nice. They bring us more customers. But it is very useful to be able to provide that extra layer of support for your customer and not have to show up and find out what's wrong and be a little more prepared when you get on site. So, what's the last one there?
Last one is if we have any features or benefits that would set us apart from any competitors.
Yeah, this is one I wanted to bring up earlier when you brought up the crane. So
Oh
yeah,
yeah, that triggered. All
yeah,
right.
yeah. So the again to start off the PLC, the way that we can integrate into different systems is a very unique solution from us in terms of the PLC integration, being able to bring it into tags that you can build your HMI screens with the rest of the tags that you bring into your system in the same exact way. That's really powerful. But speaking of specific features, the acceleration is a very unique one from us too. So we have an instead of just the sensor waking up every 5 minutes, 10 minutes, doing its sample, going back to sleep because they are battery powered sensors. The accelerometer that's on the sensor can go into a very low power state where upon seeing a certain amount of vibration, the sensor will wake up at that direct time and do its vibration sample. So this is very important in the crane application that Nick brought up. Obviously, you don't want your vibration samples to just be every 10 minutes because half the time the crane won't be in use by an operator. So we
Yeah,
apply
or it'll
this
be in a different part of the stage. Which so when you find out when you can sample at the same part of the cycle every time, you get a
exactly.
lot more trendable, reliable trends instead of a on off halfway between on off. Like so, yeah, that trigger, whether it's off of movement, off of current, off of whatever, being able to isolate when you turn on and sample is very useful. So,
Exactly. Yeah, it's even just useful for that intermittent pump too. You only want,
hmm.
if you don't want to do any data filtering on your side for if you see below this vibration that's off, you can instead use this to make sure you're only getting active samples. And as you're saying, at the same time, consistent.
Yeah,
So we can
and
use that with multiple sensing options too. So the current, we also have triggering for that 4 to 20 milliamp, 0 to 10 volt. We could bring into the back of a gateway or an IO portal, we call them,
mhm.
and do that exact same triggering. So when you see your hoist motor actually pulling up an item, you can see that current jump up immediately, set a threshold, be able to capture that current at the direct time that the vibration is being captured, which is very powerful to have that at the exact same time.
Yeah, and it's all stuff that you could do with a PLC. If you had someone that wanted to get down and write all that logic to ignore the samples when this is off or from this other data point, but being able to just have the product inherently do it is quite useful. Yeah,
And at that same time every time like you were talking about. So
yeah,
give you that
yeah,
consistent start time instead of it just being this 5 minute sample, we caught it at whatever time like you're talking about.
yeah. Well, I definitely appreciate everyone that stuck around for this entire webinar. If we don't have any more questions, if you are interested in a pilot, they're only $5,000, 3-month guarantee. If you are unhappy, you'd be the first one, but we offer $2,500 back at the end of that. So, very low risk. If you're already a foot in the door, you want to just make sure you're making the right decision. We can prove that out for you in 3 months, in 90 days. So give us a call, GraceSense.com if you're interested. But definitely thanks for attending. Appreciate your time and look forward to talking to you next month.
Thank you for your time. Appreciate it.